So please note. So this time we're talking about electrical potential. Electric potential. And in these cases, is related with capacitor. So for calculation, we emphasize capacitor. As far as the concept goes, we emphasize on potential, electrical potential. So we like to say, from the other point of view, what's the gravitational potential? Okay, so we have done all that potential energy. What's the potential energy we usually associate with in mechanics classes? In physics 31A, we have a potential energy. Potential energy is equal to mg. Basically, it's y2 minus y1. So here is some object with the mass m, and go up to here is m y1, and then this case is y2. So this is when an object moves up to certain distance, then it has stored the potential energy. So from another point of view, then you look at this is a mass m. What is g? G is gravity, but it has another meaning. This is from another point of view. This is electrical field. This is gravitational field. The gravitational field is turned out to be force per unit mass. Per unit mass. So if you look at this, y sub 2 minus y sub 1, potential energy is related to the distance, force times y2 minus y1. Basically, what that is, this distance is d. In this case, is f sub g times d. Okay, ladies and gentlemen, all it means, what's f sub g times d? So potential energy will store the potential energy is due to the work done to the system. So now instead of a gravitational force, now you have the electrical force. Okay, electrical force. So in the section 20.1, we explore this now. Here is chapter 20. Chapter 20. Section we're talking about is 20.1. 20.1 is about electrical potential. From that idea we have present that gravitational potential is due to the work is being done. So now, from another point of view, we can say that when we're moving the charge, suppose the charge is Q sub 0, we move this charge from one place to another place, so that we do the work. Okay, in which cases we like to say this is the S. So very nicely to say the work is being done. So we like to say F sub D of the work is equal to F sub E times ds. So by doing this, integration W is equal to integration of f sub e dot ds. Okay, so from another point of view, we like to say that what is f sub e? F sub e is related with the charge plus multiplied by the electrical field. So that is equal to charge Q sub 0 times E electrical field dot ds. Okay, so now depends on where you're from. Suppose you're from this is a point A to point B. So the integration is from point A to point B. Okay, now you have to figure out if the original electrical field is going in this direction. This is electrical field. And Q sub 0 suppose we're supposed to have a positive charges. So if a positive charges, suppose some place here have a Q here. So we give a notation when this from point A to point B, we put negative there to signal that. So it says that the work done within the system by the electrical field or the charged particle change the potential energy or change the work energies by this amount. So we define that the potential energy, we define that equal to minus, and like this, and integration and the minus like that. So that this is important. That means the work within the system by electrical field on the charged particle change the potential energy of isolated charge minus field system by amount of this much. So you can say that this is equivalent to the potential energy changes. In that cases, equal to UB minus UA. So with this logic, then we will get another chances. What we means in the following, that means that U sub B minus U sub A is equal to minus Q sub 0 integration A to B Q sub 0 E ds like that. So this potential energy has another term. Basically, it's related with work. So what we've done in mechanics, we are talking about W. And later on, we say the work done by the gravitational force creating a energy of position. The same thing here, by the electrical force, we're creating the energy of position as well. That we call potential difference, or we like to define that in these cases, electrical. We like to work on this electrical potential. We like to define that equal to the energy per potential energy per charge. That is